alone. Let's wing it. Welcome to class. I've been trying to be, I tried to be good about not tampering with the slides just prior to class. Shipped up this slide deck, which is really just the slide deck from Monday with a couple of these announcement things. And if you're interested in that, no links, but if the pagination, all of that. So if you want to take time, take a minute to download them from the using the links on the website, you should be good to go. Okay. I didn't think we had any announcements. I thought we were going to release homework 3 without any problems. That didn't happen exactly, so we kind of stumbled out the door with it and had to scramble around last night, but guys did great in getting it straightened out. So that homework is available. I believe we extended the due date until next Friday. So got a pretty long time to do this and deal with any of the setups issues. We're going to use Microsoft SQL Server in this homework, and you're going to be using it for the next, I don't know, 5, 6 weeks, 7 weeks of the class. So start getting comfortable with it, and I think you will. It is very different from SQLite. SQLite is just more like a file management solution. It's not really a true database management system. SQL Server, as we start to deal with it, you'll see it is a database management system. And the first aspect of it that's different is that it's a server component that's then designed to be talked to. You talk to it via some kind of client. The client and the server speak a particular protocol that's reserved for SQL Server across the network, if any of you understand how that works. And normally, what you have to do initially is to establish a connection. There's a lot of security wrapped around it. The server is either locally on your machine, or it's in the cloud in Azure, someplace in a Microsoft data center. But regardless, you still have to establish that connection, send your credentials. Okay, somebody mentioned that GradeStrip tells us the deadline is 22nd of April. I don't have a calendar in front of me, but it'll be next Friday, and if it isn't out there, I will change it on the calendar just to make sure that it sets the clock. Wrong map. See what the month of April looks like. No, it'll be the 24th, just so you know. That'll get you also through 2 more sections with the TAs who will probably be devoting a lot of their time in the next couple of sections to walking you through issues with setup and things of that sort. So it'll be the 24th. I'll change it after class. Let me make a note of that. Thank you. I told them last night to change it. Okay. Yeah. So where was I? So you need a client. So you need a client app, an app that understands the protocol, what protocol to use, will establish a connection to SQL, and then start allowing you to send SQL commands back and forth, commands. So you have a lot of choices, actually. If you're on Windows, I think your best choice is the one I've been demoing, which is called SQL Server Management Studio. There's a link there. Cost is free, so that's kind of a no-brainer. If you're out on Mac OS, I know several of the TAs in the class, they like a program called DataGrip. DataGrip was an open source project of some kind, was picked up by a little company called, maybe not so little, called JetBrains, that make a lot of tools for Microsoft developers. You'll see DataGrip. Well, DataGrip is used for databases in general, but it has a very strong MS SQL component. I put a link in there. Some people were out on the discussion board saying, it costs money. Yeah, it costs about $10. It's true. They do have a free option, and I'm not sure exactly how that works, but I have a link to it, and I think all you do is email them with your uw.edu email address, or from that address, and then they'll qualify you to get a student subscription. So they're happy to let you use it for as long as you're a student. On the other hand, if you can afford to, you guys, a lot of you guys are going to start getting paid, or maybe you already have, for programming, and you'll start to appreciate the value of your intellectual property, and that it's very nice that people pay you for it. There's a whole lot of things where people do stuff and it's open source and it's free, and they all have day jobs, in my view, or they have some alternate way of getting money out of you, like giving you a sort of strapped down free version in hopes that they'll entice you into giving them a few bucks. So, as a person who's made a living out of in the software business, I like my royalties. I like to get paid for my work. I don't appreciate people that, expect me to work for free. I can't do that. Anyway, DataGrip is a good option out there. Has lots and lots of capabilities. People really like it. JetBrains in general makes some nice tools. Alternatives in the Microsoft arena is VS Code. VS Code is a open source, open systems version of Visual Studio. That's what the VS stands for. It's portable, runs on every platform. If you do get VS Code, you have to ask for the MS SQL extensions. They're also free. There's a whole thing. Once you install VS Code, you look for the extensions, you find that one, you install it, and you'll get an experience very similar to using Visual Studio. Whoops, there, I didn't want to go there. It's that mouse thing again. All right, whoops, too far. This mouse is very sensitive, this Bluetooth mouse. Okay, so VS Code, a lot of people like it. It's a fine editor. I use Visual Studio when I'm doing something for another platform, though I do use VS Code, and they're very similar. Microsoft also makes something specifically for Azure customers, and it's called Azure Data Studio. It also comes multiple platforms. It's also free. Chris and I, who was doing the Homework 3 setup, we were sharing screens and last weekend or something like that, and I was watching what she was doing. We looked at downloading Azure Data Studio, and since I was running Windows and Chris was running Windows, we decided to opt for SSMS, but it looks like it has capabilities that are very similar. So the thing about VS Code is it's designed mostly to be a code editor. The Azure Data Studio is a little bit more like SSMS in that it's just designed for the database administrator and for doing work with Azure data sets. Azure Data Studio, VS Code, DataGrip, they all have extensions for many other databases as well. These include MySQL, SQLite, sometimes it's included in these things. Understand various, the code various stuff, like understands various languages like Python, and they do things like that. So anyway, those are your choices. Doesn't matter to me which one you use. It's whatever you feel like you're but get comfortable with it. You're going to be using it through the class, and you'll be using it in future work. Okay, so there's our links, and that's just get the time to be handy. Now, many of you, I don't know about most of you, but most are going to accept the Azure subscription and hop out and let Azure spin up a copy of Microsoft SQL Server for you and go through the homework that way. I would continue to recommend those of you that are a little bit more ambitious and want to, the thing about it is the meter's running anytime you use Azure SQL. I've got some things to try that run through the Flights database, for instance, some SQL code to show you how it works and show you how different queries compare. If you tried running them against Flights out on SQL Azure, you're going to use up a lot of your money. On the other hand, if you install SQL Server locally, you can play with it to your heart's content. So this is a very good option. It's not very difficult, actually. The couple of TAs on staff, and I'll check with see more of them. I was like, get up to speed on this, guys. Find out where they are tonight. But they found it pretty straightforward to go and do the installs. They have there are native installs for Windows and Linux. If you're doing Mac OS, you have to basically run SQL Server inside a Docker container. I posted something on the discussion board that was a pointer to how to do that. Spoke to one of the TAs, one of my TAs who did that just Tuesday. Said it was a breeze, was no problem. So you could have then access to it. Now, if you go that way, by the way, you're still going to use one of these clients on the previous slide. You're going to use one of these clients. So you always need a client to talk to SQL Server. SQL Server by itself holds the database, the data, and manages the data, but doesn't talk. You need a way to talk to it. You need a client. So those are the client choices. And these are the choices for installing locally. They have a standard edition. It's available as a 6-month free trial. They might hassle you. You'll hear from salespeople and just tell them you're a student. It'll be fine. There is a developer edition. I'm not sure what the restrictions on developer edition. It says on the website that it does everything that standard edition does, and maybe that's true. That's free, and I think it does more than Express, which is another free version. All of them, though, they only have native Windows and Linux installs. So those are your choices there. I just gave you a link to the download page, and you can try that. If you get into trouble with one of those installs, I don't think you will, but post something out on ED. What we did try to do with ED, by the way, was organize it around different categories. So when you're posting something, look around for a category to post it under. That'll help, because otherwise it's chaos. It's hard to define things. So we'll police that. I think we have the capability of also moving your content around just in case. So we'll be looking at it. All the TAs are on the alert to be checking it, but they have other work to do sometimes. So we try to get to you. I try to get to everybody, or make sure everybody's serviced by the end of the day. But if you get into trouble, you don't have an answer, you can always email me, and I'll try to get to it. Okay, so those are your options on the homework 3. And then you're going to be installing flights. The one thing we did for these local databases, we made it a little bit easier. There's a few less steps in bringing up the flights database. You basically we did a backup of the flights database, and there's a single step restore. And we put out some documentation that walks you through all that. And the TAs have been having a good time, and you guys will have a good time with it too, I'm sure. But you can do it anyway. So your choice. We're happy to accommodate you. Okay, here we are. Week 3. I forget, somebody sent this. This came in the mail the other day, and it's kind of just how things are working out here. I'm not a coffee drinker, so that wouldn't really apply to me. I don't use my car much at all. Certainly need that internet. I've still got problems here. I don't really shave, but that might apply to you guys. Sweatpants. Although I noticed that they don't always call them sweatpants. Women, when they wear sweatpants, they wear yoga pants, but men seem to still wear sweatpants. But yes, sometimes we don't get out of our sweatpants. So that is what's been happening in the world, I guess. We're homework 2. That's our first experiment with automated grading in homework 2. I don't know how well that's going to go. I don't know to what extent we're going to have to do regrading on that. We'll look at that, just to be fair. I did see a very interesting note out on the discussion board about somebody looking up to pair, and made a suggestion that when we pair up, that we take the homework assignment and split it, sort of a divide and conquer strategy works very well in parallel programming. In most cases, you do questions 1 and 3, I'll do questions 2 and 4. This may seem like a very good approach to doing your homework. I would recommend against it. The homework is not designed to be busy work, although sometimes they're rather difficult queries. they are things that are going to come up later in quizzes and their exams. And if you don't do them, you just rely on the fact that your partner did it and submitted and get the grade in the homework, then when it comes time to handle a similar problem on a quiz or an exam, you're gonna not be in such good shape. So the point of the homework is to get you to practice the features of using the language at this point. I don't recommend you do it. You can do what you want, of course. We're not policing that. It's kind of up to you. I would say, just from a grading standpoint, when we look at the end of a class and we do the grading, when we look at the homeworks themselves, they don't differentiate people very much. In other words, over the course of an entire class of 150 of you, or whatever the numbers are these days, there's very little variation in homework grades. There's a little bit of up and down, but if you kind of look at the distribution, it's flat. So none of it really differentiates you, and you're going to get a grade for it, but it doesn't really, because of the way it's distributed, it doesn't have as much influence on your final grade as you might think. So again, word to the wise, I guess, is yes, you can do that. You can game the system in various ways, and that's kind of up to you. The approach that I'd like to have you use is, we'd like to learn this stuff, and yeah, let's do it. When we think of teaming, we're thinking of paired programming paradigm, working together, another set of eyes on the code. And also in this environment where people aren't getting much of a chance to interact with people, we also thought it might be a good thing to try. So just that word to analyze. Okay, let me, let's see. So the question is about the exams, and I'm still thinking about what I want to do for the exams, but the most likely thing that we're going to do is going to have you writing queries. And the queries will give you a little bit of TDL to define some tables, do some inserts into the tables, and we'll ask you to write some queries against them. The setup will be sort of pre-set up. You just do a load of this into your whatever database you're using. It'll be SQL Server at this point. We're not going to be using SQLite anymore. Too many irregularities in SQLite, which some of you have seen. Things that really shouldn't work, they work. And sometimes by luck. We don't like luck. So it'll mostly be in the format of writing queries. Yeah, that's what we're going to be testing in the early stages. Whether or not we might do a couple of quizzes because of the format that we're stuck with here in terms of doing it online instead of having a class session. There's a time quiz. And I don't know when exactly it is. I haven't quite really worked that out yet. But in a couple weeks, yeah, we're it's like a midterm. I might do a smaller quiz and another quiz instead of one bigger midterm. I haven't really decided. We do use the quizzes and the exams to help differentiate you and get a final grade because the homeworks don't do that. So the format, you can expect a quiz will be like way more. You'll be asked to do something that you have not nearly enough time for. And that's done. It's not designed to stress you out. And if you do whiz through it, there'll be an extra credit kind of thing. That's kind of my philosophy towards these exams. Okay, I would like to cover a couple of things today in the next half hour. None of this should be real complicated. This is actually pretty kind of commonsensical, which is why it really appeals to everybody. This all-entity relationship approach came out of schools of informatics who were looking at the ways of talking about data, came up with a way of talking about data that just seemed to make sense to people, probably drew on other things that were happening in the computer industry at the time, things like knowledge representation languages or semantic networks. You see some elements of that. And it was independent of, but introduced to the computer industry around the same time as relational database management systems. And in my view, it's what's really helped people to conceptualize the way they think about data. And in particular, what we're going to be looking at is the way that how you're going to start representing that data in the database. So one of the things that's here is in the lesson today and in the lessons that the next set of lectures, you'll see that we're starting to say, oh, here's kind of the model, and this is how you turn the crank, and you actually get a database out of it, and which is still an art. It's still not a science, particularly. This whole idea of what is an entity. A lot of it depends on your point of view. As I mentioned last time, let me just go through some of this stuff quick so we pick up where we left off last lecture. So for instance, you're a software developer, you tend to think of your entities as classes. Those are my class definitions. But if you're a database designer, you're thinking about, I'm going to represent that data in tables. And we use tables because that's a relational database use. They use tables. They have a flat representation of things. We looked at this. We talked about, the racing application, the data entities that are common to all these kinds of different races. These are some of the things that you might see out of that. Okay, gotcha. So what we're going to, I'm going to have you focus on is a very useful approach, which is called the unified modeling language, which basically unifies the object-oriented approach and the entity relationship approach. And in effect, equates an instance of a class to something like a data row in a table. And that's what UML is specifically designed to do, and does it pretty well. As I mentioned, UML is illustrated in the textbook, not in these slides necessarily. I don't have too much in there, but you'll see it's pretty straightforward. None of this is difficult. You read the textbook, look at the examples, you'll be able to we'll have a homework on UML. You should be able to pick it up. Now, this is a slide I picked up from somebody else, one of many, and it talks about, okay, yes, I have this conceptual model, and then, okay, I'm going to create the relational model out of it, or my schema and my constraints. Then we're going to go through a process called normalization, which we'll deal in the next lecture. But the idea of normalization is to break out everything so that there's no data redundancies. And there are some specific reasons for that. And then finally, we're going to have our representation, but then we do the physical schema, which involves both indexing and partition. Now, I'm just giving you a high-level overview. Let's not go into all of these things. This is what's coming. This is kind of a view of what's coming. This is a pretty picture here. Talk about these stages here as if the process flows logically and effortlessly from one stage to the next, but that's really not how it works. In reality, design decisions that you make are incomplete based on the knowledge that you have at that time. A good example is a database that was designed around people having a home phone number and a cell phone number and something else. And how many phones do they have? Well, at one point, people started getting a bunch of phone numbers. And so databases that were designed to only store a single phone number. Or think about, if you use a purchase online, they store your credit card information. But, I don't want to use that credit card for this purchase. I might want to use a different credit card for that purpose. This assumes you have more than one credit card. You guys probably don't have any, or maybe you do. I hope you do. I don't actually have any desire for you to have one or not have one. But, now instead of having, you have to have a representation that allows multiple credit cards, and then a designation in the how am I going to pay that says, select this card. So these kinds of things emerge and they change over time. So I view all of them, you see them, you come at them 10, 15 years later when they've been built and they look beautiful or complicated, or there's a lot of inconsistencies. They're all provisional, but they're subject to continuous incremental improvement. And one of the things that relational database technology allows you to do that we had difficulty with before they came along, was make changes to the physical structure of the database without affecting existing stuff. So they are possible. You can change it. You can modify schemas. You can alter tables. You can add fields. So today we're going to be talking about the first two parts of it. I drew a little box around it, the conceptual model, and then how the conceptual model starts to translate into something that you'd actually, a schema, the schema that you'd write, the DDL that we've seen that defines the tables and all the fields. We're going to look at normalization in the next unit, and then we're going to spend a bit of time on the physical database, which I think most of you will find challenging. This part, I don't think you'll find challenging. It should be relatively logical. These entity relationship models, they're visualized in some fashion like this. I put a link into a tutorial on how to do this. The building blocks for them are pretty straightforward. You have an entity set, are these rectangles. The relationships are these diamonds. You know, if I turn my head around, no, I guess it's a parallelogram. It's a diamond, okay. The attributes of an entity are pointed in these round oval things. And that's pretty much it. You show which ones are connectors. So the product, there's a company that makes a product. There's a person that buys a product. The company employs a person. Maybe, I don't know, whatever the application is, whatever the model is for that design. So we have a way of representing them this way. This is not a very compact visualization. You'd have pages and pages of it. And in fact, when you start working in industry, you'll find that people don't use this because it takes too much room, too much paper, too many screens. What they use instead is the UML, which I'll show you what that looks like in comparison. But anyway, this is the diagram building blocks: the entity set, the attribute, the relation, the subclass, something that we'll call a weak entity set, which we'll see it's not quite a subclass. It is what it is. I'll show you what it is in this approach. UML building blocks are just tables. They also are used for class diagrams. And these are connectors that are showing the relationships between these tables. They usually also are indicated. You underline things like primary keys, or they're flagged somehow. So UML is much more compact. It's more text oriented. You will encounter these. These are much more common. They take up a lot less space than the other kinds of VR diagrams, which may be more interesting visually, but just take up too much room. Basically, in what are entity sets in ER, in UML are called classes because it's also designed to be able to model object-oriented programming. And relationships, we're going to see a term called multiplicity, and I'll explain what that means in a minute. It's kind of an odd term. It doesn't convey the term doesn't convey the concept very well, but I haven't really been able to come up with a better term. I also put a link out there. There are free packages that let you draw these things. This is what people do use. So I recommend that. There's a nice section in the book on it, or go out to this website when you're doing your homework and you'll figure it out. None of this is really hard. Okay. An entity corresponds to an instance of an object. So an entity, we had a racer on a bicycle, or a racer on skis. That racer would be the entity. The entity set is the collection of those racers. So that's all it means by an entity set. It's a collection. An attribute corresponds to a field, and yeah, these are collections. Entities of the same type are in an entity set. In ER diagrams, you underline the attribute, which is the part of the primary key, something that uniquely identifies that instance of the entity. And right away, we start thinking about these entity sets and this part of it, you're thinking about, how do I map that to a database? How do I select it? How do I search for it efficiently? Okay. And this set of entities here, this entity set with these attributes, should be pretty straightforward, that translates into a table called person, that it has a person ID, which is an integer, and it's my primary key, and there's a text field, and here's a text field for the name, and here's a text field for the address. Now it starts getting more complicated than that. Do you want to represent a name as I'll get to your question in a minute, as a name as the whole name? And then when you search by last name, you got to constantly pull it apart. Or do you want to represent it in the database as first name, middle initial, last name? What about somebody like my younger daughter who has a first name, a middle name, and a hyphenated last name? Where does that go? Actually, Social Security Administration does not support that. So I think on Danielle's birth certificate, she just has 3 names. She goes by 4, but it's not represented in their database. So those are the kind of decisions that you make in terms of design, and there are trade-offs involving that. Every time you want to print out the full name, if you have the name in a text field all by itself, you just print out that name. If you don't have the text field, name in last name, first name, middle initial, or something like that, then every time you want to print out the name, you got to write some code that pulls it together. You'll write a routine that pulls it together, or a function, so maybe it's not that big a deal. So let me look at that. Are connections between different parts of the model viz directional? Yes, we'll see some of that. We'll see what that means. I didn't want to go into detail about that. Between entities and relationships, there's something that we matter, that we care from the entity to the relationship, and we care about what we call the cardinality of the relation. I'll get to that in a minute. What is the difference between plus and minus in SQL database implementation? The database also has methods. I don't think I understand the question, so why don't you raise that toward the end of the afterwards. I'm not sure I can answer that because I don't understand what you're asking. All right, let's move on a little bit. So basically, we've got a bunch of slides that I'll go through pretty quickly. If you're following along at home, you'll see that we've got product entity set, and here's our representation. We've got a relationship that makes, and we've got a company. These are the companies that make these products. And basically the idea is that if you have if A and B are sets, then there's a relation R that's a subset of A times B. In other words, you can join these somehow. That's what you're looking for. This set theory a little bit. That is not a particularly profound result. Oops. Keeps doing that. Sorry about that. Oh my goodness, boy, it jumped up about 30 slides. Let me finish up where I am here. Okay, so here what we've got is a company named Hasbro, and it makes a product called a Beyblade. I don't know what that is. Here's a company called Knifeform, and they make a product that's a troll. I guess this is a toy company. They make toys, or maybe it's the toy section of a bigger company. That's what we're just considering conceptually at this point. And here's the entity relationship diagram that shows those relationships. Okay, now we're going to get a little bit more complicated, and we're going to talk about relation cardinality. So sometimes, for instance, and we've seen this, and this is where database designs get it. So somebody's missing out on the Beyblades. Is that like a skate? What is that? Like an inline skate of some kind? It's like a top that can hurt you. I am not familiar with it. Probably wasn't around when my kids were growing up. Okay, so think about relationships. Think about inside of our entity set of people. A lot of the relationships are one-to-one. This person has one name. This person has one home address. This person, if it's a customer, though, might have many ship-to addresses. might have a billing address that's separate. So sometimes we're one-to-one. Sometimes we're one-to-many, or the reverse of that. And there you see the diagram, the arrows. So one-to-one, you put an arrow on either side. I don't know why they came up with this, but that's just remember the rule. So no arrow means many, and an arrow on the other side means many to one. One to many is just the opposite side of the same relation. So a person might have many phones. Doesn't have to have many phones, might not have a phone at all. I don't know how they live these days, but without a phone, but they might not. Maybe they lost their phone. Maybe there's something. Maybe we need to keep track of that. And some relationships are many to many. For instance, if Beyblade is a popular, or maybe trolls, I know them. Lots of different companies may make trolls, and they make different kinds of troll items. And you might want to characterize them. So when people are searching for, they need to buy trolls for their 5-year-old or whatever, maybe 15-year-old, I don't want to say, when they buy trolls, that they can see all of the entities that are related to trolls. So again, how you represent the data in your database also leads to how I can search for it. That's why this organization is interesting. How I can search for it, how I can find it easily. Okay. So another term is introduced that associated with cardinality. Cardinality is just, order, is a number. It's the size of the relationship. The other term that people use is multiplicity, because it's not necessarily just a size. It could be that you don't have to have a phone. You could have one phone, or you could have many phones. In other words, there could be 0 instances of the relationship, but there's still potentially a relationship there. So in UML particularly, multiplicity specifies the lower and upper bound constraints on the cardinality of a relationship. Okay, let me show you what that means, because it's pretty straightforward. So here's the UML definitions of multiplicity on the left. In the middle is how you would abbreviate it. So a collection, you can specify in UML that the collection must be empty. It doesn't exist. And you would call that, I don't know why you would represent it that way, but maybe you would for some logical reason. So that you would call that a 0. You could have 0 or 1 instance. You could have exactly 1 instance. So I just put a 1 there. You could have 0 or more instances. That would be 0 to some wildcard character. That's usually the wildcard character, and when we're parsing things. So that means many, many instances, no limit. You could have 1 or more instances, but up to some number. You could have exactly 5 instances, whatever the rule is. So whatever the rule is, that you get 5, you get 4 days, late days in this class. That's it. You have exactly 4 that you can use. And M to N in general is at least M, but no more than N, whatever those constraints are. That's called multiplicity, and it's cardinality with sort of conditions on top of it. Okay. I haven't got any more, so pretty straightforward. Okay, now, so in UML, multiplicity specifies the lower and upper bound constraints on the cardinality relationship. What we're going to see, and that's what I want to get to today, so much of my time, is an active mechanism at the database level that enforces multiplicity rules. And these can include constraints, and that's the keyword that you use in SQL. Primary key is a constraint. Unique is a constraint, that the values of this key are each unique. We've talked a little bit about the foreign key constraint, and I want to now dive into the referential integrity associated with that. And we also have things called check and default, which I'll mention quickly. There's also built into the DBMS something called triggers, a much more general purpose. It's used for many things more than just this, but it's a set of SQL statements that executes on the database server when specific events occur. So a specific kind of insert statement, somebody's defining something, even login events are all associated with triggers. You could also have triggers, I believe the trigger at a particular time of day. So you could have some process that kicks off at 10 p.m. or something and roams through the database for whatever reason. All right, so we want to get into that. Okay. Basically, I'm going to use these terms. They don't seem to be in fashion at the moment, but if you think about SQL, you really have two kinds of statements. You have statements like create and alter, create to set up tables and columns and things of that sort. And alter wants to make changes to them. And that's data definition language, or DDL. So I use that terminology. I do find it useful. DML is the data manipulation language, and that's used for select, insert, delete. So you're getting some practice in that. You're going to start to see, in this lecture, we're going to be talking about DDL, which is where we do things like constraints. Okay. So we've got entity sets. You can see that they're roughly analogous to the tables. Attributes are roughly analogous to columns. And then relationships. What do we do with relationships? That's an interesting subject. I guess we're not going to get to constraints today because we're going to be talking about this for the next 5 or 10 minutes. Okay, so we've got this conceptual model that leads to our schema. Now we're introducing things like constraints like primary key, unique keys, and foreign keys. So we've talked about them a little bit. There's even a key, a data type that you'll see in MS SQL that's very clever because it's used quite frequently to generate a unique ID field. In fact, the kind of field it is called an identity. And it will generate a unique field automatically when you insert something into the database. So you don't know what the employee ID is. This identity field knows the table and knows what the highest number is currently, and automatically increments it and returns when you do an insert. You don't have to specify that field because you don't know it yet. So it does it for you. In the past, without that kind of stuff, that would tend to be a confusing bottleneck as people needed to decide, insert or define unique identifiers. So they've got this nice thing, which I think sure they copied it from Oracle, is a field called identity, which people will use. Once you have this relational model, then eventually we're going to get to the physical side. How do you define the indexes and talk about the types of things? Okay, one-to-one. We have here a relationship where one company, Hasbro, makes the Beyblade. One company, Knife Form, makes the Trolls. That's how that would look. Pretty straightforward. That means, yes, we would create a table called product, create a table called company. We create a table called makes products, say, that actually references the company. And actually, that's not quite right. You have to reference the company and the particular field in the company. But this unique constraint, and this is explicitly representing the relation. Question we have to consider is whether that's a good idea, and unfortunately, the answer is it depends. It depends on you need to know more about the problem. Both ways might be correct, and we'll show you examples of both ways. Out of time, so speeding up here. Obviously, to find the name of the company that makes a product, using SQL, we need to join the product tables. And the question here is, do we need a separate links table like this? And as I said, the answer really actually is it depends. Okay, what else do we want to show you quickly? We want to show you the way we tend to do it in, this is a one-to-one relationship. And the way you do it in using a foreign key reference is to point to the other table and the field name. And we're giving that a different name because name is being used someplace else. So you have to disambiguate this for the SQL Server parser, but that's a one-to-one relationship. That says because company name is a primary key, there's only one item in the database with that particular name. So references in this case sets up a one-to-one relationship, and you don't have to model the explicitly in a separate table this makes relationship. It's embedded into this into this schema using the referencing. Okay. So we create a foreign key, no need for a separate table. Just laughing at myself because I often don't need the slides, but there puts things on there that I use to remind them. Now, just remember, we haven't fully discussed constraints yet, so, and we're probably not going to get to it today, looks like. So we'll get back to that discussion in a minute. But let me show you some more. So here's many to many. Hasbro makes many different products. Nifor makes the trolls, apparently. We've got also many to one, where Hasbro, there's many companies that make these troll products, and you would show that this way. And again, we've got the question of whether I should use a relationship so an M-to-1 relationship, each product is made by one company, but each company makes many products. How do you want to represent that? Again, so it makes it nice and searchable and consistent. Okay, again, relations can have attributes too, as we talked about. Those are basically the fields. The rounded arrow, when you use this kind of diagramming, means that there is exactly one and most one. So that's how these pointers work. And these connectors, it means there's just one and at most one. So you see that. And if it has to exist, you specify that the field cannot be null. That reference must exist. Primary keys, by the way, also, it's assumed primary key means not null. It's just assumed because it cannot be null. You can't define a primary key on a field that could be null. The database won't know what to do with it. So let me finish up with, okay, now let's look at multi-way relations. We got the products, we got the company, we got the person, they're making a purchase. And the question is, that's just some set theory, is a purchases, I'm so sorry. And I'll finish up with this if I can find the slide. Is a purchases link table useful in this case? When you start to have multi-way relations, sometimes it is useful, I would say, to have something like a purchases table. And I'll show you why, based on slides that I picked up that basically wrong. But so here's my product, here's my company, here's my person, here's my purchase. So in the purchase relation, which is kind of a relationship link, we've got the company name, we've got the product name, we have the purchase ID of some kind, and we're calling this, we're creating a primary key that's C name, P name, and the product ID. Company name, product name, PID, and we're saying we can look things up there. Anybody see a flaw in that? Anybody spot a problem with that model? Well, I'm a company, and you went out and you bought Beyblades, hoping that you'll buy Beyblades again. And in this model, there's no way to represent that. The fact that I might purchase the same thing over and over again, and I want to be able to do that. And this is very suggestive to me that you actually need something like a purchase order entity and generate something like a unique purchase order ID. So that use case where a person would buy the same product more than once is it's caused problems in this model. And since you want to be able to support that, you want to sell this frequent flyer person the same thing over and over again, you probably should not do it that way. You probably should do it, see if I have this. You'd probably want to do purchase orders, the purchase order ID, person, order status, etc. And then you'd have the purchase of the particular products. You also then start to look at an e-commerce business, does it ship together? Things like that. And this is how entity model and data models change as new as new requirements come into play. Oh, we're going to ship this. We're going to make this, where is it in the warehouse? And you start to build more and more complexity into your data models. Okay, I think we're out of time, so that seems like a good place to stop. We'll pick up next time with the specific constraints that also map into from the entity relationship approach, modeling the conceptual model, and how they're supported. The one that's interesting, most interesting, is foreign key constraints. And the question is, well, what happens when the foreign key no longer exists in the main table? And as you can imagine, that's something that could easily come up. That would be a referential integrity, an issue of referential integrity. And the database management systems are designed to maintain the referential integrity. And I'll show you the mechanism that's used there. Okay, any questions? Doesn't look like it. All right. Good luck with the homework. I'll see you again on Friday. We'll pick up here where we left off. Yeah, I'll switch over to the other meeting in a moment.